In summary, GIS guy by trade and have been working kind of on the business development end and with Teren for some years. Good to be back at Energous. Presented here a few times, both with Teren and in previous lives, I believe, as well. Going to keep the landslide theme going here a little bit, at least in context of the use case that I'll reference. But at a broader viewpoint, really what my presentation here today is, it's all about data triangulation, right? Which I'll be mentioning that throughout, right? And as the title says, in a slicker manner, from silos to signals, right? How are we going from individual data silos, bringing that together in a uniform manner, right, to help with decision making? And this is going, again, to be focused on a use case landslide related for one of the operators we work with here in Appalachia that has been, had a landslide management program, a geohazard program in place for a long time. They got a lot of data, and I'll kind of tell a little bit more about this use case as we go, but in summary, so much data, they were drowning in it. How do we take all of this data, not only to understand where we're going to spend money, where we're going to send resources, where we're going to focus, right? And we're finding these different ways to integrate these different data sources from the terrain intelligence that could be LiDAR-based analytics, where we find these geohazards, we rank them, and perhaps we monitor them over time with multiple LiDAR runs. Last year I was here very focused talking about real-time weather. We've heard that come up in a number of presentations as well. So how can that then be layered in as well? And then looking at other data sources such as bending strain. All of these, right, coming together for kind of a more proactive, in this case, geohazard risk management type of program. Yeah, right. So, the challenge here, right, and again, we've heard from previous presenters here where weather, terrain, where these interact, and as it relates to the critical infrastructure, right, that's this convergence of risk. So how many are representing an operator that has pipelines? Most, that are many, a few, right? This could apply to any critical infrastructure, right? Any location on the earth that's subject to environmental risk, right, really could fall into this. But again, I'll be covering a use case here focused on landslides for a pipeline operator here in Appalachia. How many of you are already bringing in some type of real-time weather feed into your GIS? Handful? Right? That in itself, not a novel thing, right? It's become more prevalent. I mean, we certainly all have weather on our phones. We're starting to bring that into our organizations as well because it's a key component, right? How many of you are dealing with, now I'm going to get into rhetorical questions, complex terrain. If you're in this region, if you're in Appalachia, it's complex, right? You can't throw a rock without hitting a landslide, basically. And even more rhetorical, I know you're dealing with critical infrastructure, right? That's a big driver here, is how do we help manage the digital data for these critical infrastructure, right? To get to the decisions that integrity, operations, damage prevention, other users might need. And so all this comes together. It's a continued pressure on not only pipeline integrity, but the GIS departments that work alongside the operations, the field operations, and so on. And so it's certainly this convergence of risk. So, in the past, and to some extent in many ways now still, right, there's disconnection. Is this something you experience, disconnected data, when you're trying to pull together information, analysis, and answers for your users? In the context, and I'll back up a little bit here. Let me give the kind of general use case here that all of this is driven from, and I'll get to some examples of how the operator is pulling this data together, right, and trying to address this issue. But as I mentioned, one of the operators that Teren works with here in Appalachia, year over year, we're analyzing LiDAR data, and in this case twice a year, right, to identify, prioritize, and because it's year over year, monitor these discrete locations of landslides. Great. It's a great business model. It's what got us where we are today. But it got to the point, we're talking hundreds and hundreds and hundreds of slip locations. And continuing to throw that over the fence to the operator, here you go, to the point where they said, we're drowning. We're drowning in data that you're providing here. And yes, we can help with an initial assessment of ranking those. Where does that slip live in relation to the pipeline, right? Is it translational? Is it rotational? Is it moving towards the pipe? How big is it? What are the hydrology analytics showing here? So it's good information, right? But at some point, with hundreds and hundreds of these slips, and not enough time, not enough resources to do the mitigation work or even the monitoring work that they need to do, it became just drowning in this. So it's so much data, we can't even make value out of this unless we find a way to help prioritize this. So this is where this started, and this is where we started to uncover some of the older paradigm components here of the disconnection. And those geotech assessments, right, and that may be LiDAR-based assessment, it may be geotechnical engineers going into the field and doing more detailed assessments, whatever that might be, very important information, but it can be static and periodic, right? Even if you're doing a LiDAR run twice a year, it's still static in between. There's still a lot of information you can gain there, right? And it's a singular point of reference, right? A singular data source. So we look at weather, right? Last year I was here and most of the conversations I have some type of real-time weather component to it. But how does that weather relate to that specific asset or that specific hazard, right? And can this be something that's brought in as well? And through the course of this, that still only gets us so far. Maybe we've whittled down from 1,000 slips to 500 slips. Well, we need to get this down into the tens, right? So what other data sources are there that can help us start to have that data triangulation? So IMU data, bending strain data from these ILI runs with the special sensors that can find bending strain. Again, vast, big data sets. Can we start to triangulate with IMU data, with the geotechnical information, with real-time weather, right? And then we've also got even just our static risk maps. So the risk teams within these organizations maybe are updating that once a year. All these different data sources, right? There's a temporal component to it. There's a snapshot of what that represents. And if they're disconnected, it's hard to get to these answers. So the attempt here is really to move towards a more unified view, right? And what better tool than GIS to do so? Now, we'll get into some of the challenges and obstacles that have come up there, but as I get through here, we'll see how leveraging GIS, right, to bring this unified view together really came together. But if we can start to then take some of that information, right, and start to analyze that and present that in a way that starts to corroborate, right, starts to bring in this information that can give us confidence on the decisions we're going to make. And that, again, the terrain intelligence, right? We heard in the last presentation a lot about the factors that go in there from the terrain, the slope, the soil components, right? Again, snapshot in time. The real-time weather, now we have something more temporal where we can understand as precipitation comes, how does that interact with the landscape? But again, it's not as simple as saying a storm came through, we know there's a landslide here. Not every storm is the same. 2 inches in Pittsburgh is different than 2 inches in Arizona, right? And not every location is the same. Even if a lot of those parameters are the same, the landslide itself may be dormant, may be more prone to reactivity. Perhaps it's very stable, a lot of regrowth, or they've already done mitigation work. How do we know that they've done mitigation work? Well, that'll come into play here as another triangulation point, and it's been mentioned in previous presentations, right? Remote sensing can take you so far, but there really is a need for that field level information, right, for a validation as well. Now, I've kind of focused, and as a company, we've always focused on these terrain-based, remote sensing-based analytics. Can we take that a step further to understand, again, where we may want to focus those resources? And this is where bending strain, it's not a silver bullet, but it can help provide another data point, right? Can this sensor show me, well, I have some bending strain, it's near a landslide, perhaps there's some correlation there. Perhaps I need to inspect that further, right? All of this then is going to help us with these models. A model is only so good, it's rarely ever perfect, right? Can we make this more dynamic so that these hazards and the consequences that we're modeling become more accurate and more usable? So as I mentioned, this power of data triangulation, right? A lot of what we typically work with is spatial, right? My first GIS class, my favorite GIS professor, it stuck with me when somebody said, what is GIS? And he said, what is it and where is it? If you really boil it down, right, in its simplest form. Well, if we can add a temporal component, we can also understand when is it. And that can be really important. That's where real-time weather comes into play, but there's other pieces here as well from a temporal perspective. Hopefully this helps us reveal this kind of compounding risk. Because again, a single data point might show that one location is a low priority. Perhaps we did identify there's a slip there, but we've kind of said it's not something we need to worry about. It's off right of way. But is there a field inspection that went and said, you know what, actually, it looks like there's some movement here. It looks like perhaps the mitigative work we did last year didn't take. Is there recent weather that has potentially affected the stability of that hill slope, right? So if we can start to compound these data points, it may generate more of a critical signal, right? It may kind of break apart and sift through the noise, which was mentioned earlier as well, right? Why? Why do all this? Because in the real world, we're dealing with limited resources, limited time. Just because you have 300 slips doesn't mean you can go fix 300 slips. And before we even get to that, we may not even need to fix all 300 of those. But even if we boil that down to 20, we may only be able to fix 10, which is, not, it's not bad, but it's not all of them, right? So how do we choose which 10 to fix? Or in a real-time scenario, how do we choose where to send that field crew first, whether that's from a regulatory perspective or just purely operational to try to ensure uptime with that particular asset. So a couple of examples here how this is being used. And I'll jump through a few. This particular use case, right, would be a scenario where the operator has a landslide inventory. Most in this region do, right? Major storm system passes over the right-of-way. Well, in the past, and in many cases still now, this might be an operations manager calling the other operations manager, hey, how much rain did you get? And this is a true story, right, from an operator we work with today, how they've been doing it. Well, I got a couple inches, it didn't rain here. All right, let's send the field crews over there. Again, there's some value there of kind of the local knowledge, right? Or it might be, well, send the right-of-way patrol plane, out. We have to meet this PHMSA regulation, 72-hour rule. We're calling this an extreme weather event. And hopefully they see something, right? So these can be helpful. They can perhaps check a box, right? But are we using the data at hand in a way that can help pinpoint where we really should be focusing? And in this case, in a post-storm inspection, we can start to integrate some of this data here, right? So I'll get into some detail kind of on how we're modeling how much precipitation matters, right? I'll get into that here in a moment. So we can figure that out, and we can say, all right, you've crossed that threshold, you have a known slip here, it's rained, but that may still result in too many locations to inspect. So again, can we triangulate that further? Say, well, do you have known bending strain that you've been concerned about near any of that? Do any of those field inspection reports that have come in make one more important than another or perhaps riskier than another, right? And so we can start to highlight those locations that may matter most. And so field crews then are going to be more precise. I don't know about surgical, but far more precise perhaps than just this, let's close our eyes and throw a dart, or let's just get everybody out there and hope that they see something. Now, in this case, right, you may not always have that knowledge of where a slip exists. So we're getting into something proactive here to understand along a right-of-way where that risk may be that we don't yet know we have a hazard. Okay? And so I won't go into great detail here. We do have a white paper on kind of methods and validation for this factor of safety-based approach. We call them geostrata, but if you can see in the screenshot there, a couple of random-looking polygons, right? Some orange, some yellow. In this case, the orange denoting what may have been triggered by a precipitation threshold being exceeded. Well, each one of those is this individual unit that we can use when we don't know that there's a landslide specifically at XY location. And that's going to be based off terrain. It's going to be based off soils. I'll go into just a little bit of information on that here. But then in addition to the location and understanding those variables, it's not always just, hey, tell me if it rains 2 inches, right? Because it may be a long period of rain. Perhaps it's a ½ inch a day over a 30-day period where saturation is being hit. And statistically from the work we've done and the validation we've done, most of those are occurring over a long period of saturation, which would make sense, right? Some of these places can handle a flashy storm. So it's not only the frequency, it's also the duration and intensity of these precipitation events that need to be taken into account. And this is whether we're monitoring a known slip or we're monitoring a right-of-way in general, right? A lot of this needs to come into a play to again, kind of break that down and tease out what's important. But again, we can start add in these other data sources as well to help further triangulate that. I will go briefly into kind of this factor of safety-based approach for these hill slope units. And really it boils down to terrain, like percent slope and soil properties. So basically this factor of safety numerical value, right, will state that if it drops below 1, that hill slope is failing, mathematically speaking. Doesn't always necessarily mean a landslide is going to occur, right? And so above 1 is going to be a more stable slope. But it's a way in which we can define numerically at a given location, based on soil properties, based on terrain, what is that kind of baseline factor of safety? Now, you can then bring in this case, we're using like the NOAA 14 Atlas, which be a matrix of understanding that frequency and duration of precipitation. Think 100-year flood, right? At this location, within 100 years, we should expect it's going to get 2.6 inches of rain at some point, right? Or whatever that number is. But it creates this dynamic way of looking both, again, frequency, duration. Is this a 100-year event? Is this a 1-year event? Is it a 1,000-year event? Are we looking at this over 1 day, 7 days, 30 days? Right? So there's a lot that you can start to boil in here to understand where should we care. And it's great. And our white paper shows fantastic validation, but it's still not perfect, right? And it's still not going to tell you, yes, a landslide is happening right now. It's never going to do that. So this is where, again, data triangulation. Where else can we bring in these other data sources? Because, yeah, we think we're pretty cool. We came up with this model. The numbers look great, but on the ground, in the real world, when you have limited resources, limited time, you've got to be able to have these other data points that are going to help give you that confidence. So if you're interested in more detail on the methods validation for this, come find me afterwards. We have a white paper. You can probably also get it from our webpage. But the other use case here, and this is something, and then I'll, if I have time, show an example here where, again, we brought this into a dashboard. It's a great use case for an Esri dashboard. But it's not always raining, right? So when we first came out of the gates and we were so excited about this real-time precipitation monitoring, and a lot of our great customers said, yeah, let's do a pilot, and then it was dry for 3 months. We said, well, we can't really prove it, right? But what we realized is that not only are we looking at this in real time, storm comes through this location, if it rains more than 2.5 inches, we're going to let you know, generate that automated email, so on and so forth. But all of those precipitation events are being recorded, right, and being maintained. And so what we found is that that data, and now more so coupled with these other data points, can be very helpful from this planning and prioritization perspective, right? Especially when you're dealing with, all right, I got 100 slips, I can only fix 10 of them. Which 10 am I going to fix, right? And so this is where we can bring in that weather data, how many times that location got hit, bring in that field inspection data. I was having a conversation earlier, you know, internal to your GIS, you're already doing this. You're taking the Teren landslide data, you're taking your field observation data, you're bringing it into your Esri environment, right? We've had folks start to talk about other data that we can bring in. Sensor data, inclinometer data, right? IoT data that's on site. Can we bring that in? Change detection, you know, looking at the folks that use LiDAR year after year or multiple times a year, that change detection piece can come into play as well. Let's see if I'm able to, I may not have enough time here, but I won't go to the live demo, and it's kind of hard to see here, but be happy to show folks if I've got time later. The dashboard itself, right? Probably most of you have built more beautiful dashboards than this, but it's the data behind it, right? And the ability to leverage these vast data sources and boil them down to get to some answers. So for example, at the top here, this is looking at all of the data, all of the landslide inventory. How many times has it crossed that threshold of precipitation? What are the existing field inspections, you know, the data, the pictures they took associated? The bending strain data is in here as well. But I want to maybe break that down over the last 3 months what's happened, or over the last year to help me with planning. And so as I would do that, each of these widgets would update and I'd start to narrow that down. And especially important over here, again, hard to see, but these are each of the individual identified landslides for this particular operator. And how many times has that alert been generated, that threshold been crossed? So this could come down to just a straight up tiebreaker. I've got 10 slips to fix. I know I got to fix these 8. What are the other 2 going to be? I've got a handful that are kind of, you know, in the running potentially. The rest I got to move to next year. Well, this one got hit 5 times, you know, with a precipitation alert. This one got hit 3 times, and it's next to a known bending strain. This one got hit 3 times next to a known bending strain, and let me reference the field observation here where they took some pictures, and yeah, this is one that picture's worth 1,000 words, right? Shows far better in a live demo, but I'm not going to try to roll the dice on that given time here. So again, you know, as I mentioned, we have kind of these canned dashboards that I'm referencing here, an experience builder application here. Very often though, again, the power's in the data and in what you can do with it, right? So often this is being delivered to you as the GIS professional. You're bringing that into your system, your dashboards for your particular use cases, or they can be pre-configured or some type of hybrid in between, right? But we are leveraging Esri and Experience Builder dashboards in some cases, again, whether it's us, you internal, another vendor who's building out a Survey 123 or a Field Maps application, trying to bring all of that together. So, sounds great, right? Easy to do, never any problems. The end, thanks. No, there are challenges, right? And there's probably nothing on here that you don't deal with day to day, right? Data interoperability. So I talked about these different data sources. Sure, we've got some core GIS data, vector, raster, representing landslides, representing the terrain data underneath. we want to bring in all the ILI data too. Well, you're using 3 different vendors and they have 3 different formats and it's a CSV, so there's work to be done there. There's definitely this data interoperability. Sensor data, don't even get me started. That's locked up. You can only get it from their website, whatever the case may be. So ongoing issue that certainly everyone has to deal with. We're talking big data at scale and then adding real time. So processing that data at scale, that's always something to be keeping an eye on, making sure that there's not a lag in that information, that you're getting accurate data. And then, of course, organizationally, breaking those silos down. Hopefully this is something that continues to improve. A lot of folks that I work with, there is a lot of collaboration between GIS, integrity, operations, damage prevention, you name it, right? But that can be difficult. Some of the bigger changes, right, is building the trust in the system. A lot of what I'm talking about is model driven. And yeah, we can show, hey, true positive, true negative, great mathematical results here in a white paper, but how does that translate on the ground? And so we have to build trust because it's also something new, trying to bring in this factor of safety approach, looking at precipitation, and how does this align with these other data sets and data sources. With that comes change, right? And change can be difficult, so change management certainly something to be aware of as well. And in conclusion, right, a lot of this is trying to move from reactive to proactive, which that can have some challenges as well. But if we can help get a better understanding how to proactively get to a location and address that location, it's going to save that operator money, uptime, potentially eliminate a potential incident, so on and so forth. Getting from this uncertainty to confidence. Yeah, there's a slip there. I don't know what to do. Can we bring these different data sources together to provide more confidence? Again, that data triangulation. So that they're data-driven decisions, but they're backed by multiple sources, right? Not just one remotely sensed data set that says you have a problem here, that data triangulation. Make it scalable, make it usable, to help improve these weather external force threat, these geohazard programs. And hopefully this becomes more resilient, more cost-effective, and certainly safer operations as well. So I'm probably out of time, I'm pretty sure. Thank you. Please find me if you have any questions or want to see that. And I actually would love to see your examples of how you're bringing this data together, your dashboards too. So please be happy to chat.